Hi, friends. I am in your packet. We're in section 8.4, page 606. And I wanted to remind you that for right now, I'm only making videos for the guided practice in sections 8.2, 8.3, and 8.4. So if you need any additional videos, things that you're struggling with, please, please, please email me, and I would be happy to make a video for you with any of these problems, okay? I just noticed people weren't viewing these as often, and so I think the packet is explaining things for you using the videos that are embedded and the examples in the book, which is a good thing, right? So, all right, if you need me though, let me know. Okay, so this says a school cafeteria sells lunch passes that allow a student to purchase any number of lunches in advance for $3 per lunch. It says we're going to write an equation. It's going to need a variable. It's going to need an equal sign and at least one operation. That's an equation, right? To find T, which is the total cost in dollars for a lunch pass with N lunches. Okay. So the world might be a little simpler if it was just X's and Y's all the time, because you know that your X values are your input and your Y values are your output. The N values are the things that you change. And when you change those, the Y values change because they depend on those X values. Well, there's no X and no Y. So you've got to think about what is the thing that we're going to change in this. Okay, so what's our independent variable? And it says we're going to write an equation to find T. Okay, so that's kind of a clue. If we're finding T, usually we write an equation in terms of Y, in terms of the output, what we're trying to find. So T is like the output is equal to total cost in dollars for a lunch pass with N lunches. How much is one lunch? $3, right? So we have to pay $3 per lunch. That idea of per is going to come up a lot in these relationships that you're building, these functions, because most of these that are in this section are called proportional relationships. They go through the origin. It's not going to be like 3n plus 4. They're going to go through the origin. So this is the equation that goes with this one. Let's try number 2. Make a function table. So now we're doing a table to show the relationship between the number of lunches in, right? That's kind of our X value, our input, and the cost T. So if I get one lunch, I have spent $3. If I get 2 lunches, I have spent $6. If I get 3 lunches, I have spent $9, right? Because T is equal to 3 times N, N being the number of lunches, okay? Now we're ready for the next representation. So we've represented it using a table, and now we're going to represent it on a graph, because anytime you can make a table of inputs and outputs, you can also graph it, all right? So one lunch is $3. That's going to go here. And 2 lunches is going to be $6. It's going to go here. Okay. And 3 lunches is going to be $9. Okay. Now, your book kind of infers that this is going to make a line, and you could make a line. You could draw a line, because this is linear. It's a linear graph because it has a constant rate of change. Okay, so what that means is, for as I go over 1, I go up 3. Over 1, up 3. Another way, up 3 over 1. But this is really what would be called a discrete function, because you're never going to get half a lunch. So you can't say 1.5 lunches would be right about here, right? Because you're not ever going to do that. So a discrete function instead of a continuous one. That's a preview for 8th grade. All right. Hope this helped.